Hello students, in this we are going to find out the method of finding the numerically greatest term in a given binomial expansion. So let's suppose that we have a binomial expansion a plus b raised to the power of n, where n belongs to a set of natural numbers. So in order to find out the numerically greatest term, first what we need is we need to find out the value of m, which is nothing but equal to n plus 1 divided by 1 plus mod of a by b. So if m comes out to be an integer, then there will be two numerically greatest terms, and they will be tm and tm plus 1. But if this does not come out to be an integer, then our numerically greatest term will be equal to t of greatest integer function of m plus 1. So let us now illustrate this with a particular example. So we have now to find out the numerically greatest term in the expansion 2 plus 3x to the power of 9 if x is equal to 3 by 2. So let us now find out the value of m. M will be equal to 9 plus 1 divided by 1 plus mod of a is equal to 2 in this case, and b is equal to 3x. So now replacing the value of x over here, we get m to be equal to 10 by 1 plus mod of 2 by 3 into 3 by 2. So this comes out to be equal to 6 plus 12 by 13, which is not an integer. Hence, we will now require to find out the greatest integer function of this value m. So this will be equal to 6. Therefore, our numerically greatest term will be equal to t of 7, which can be now written as nc6 for this particular case, 2 to the power of n minus 6, 3x to the power of 6. Replacing the value of n, which in this case is 9, we get 9c6, 2 to the power of 9 minus 6, 3x to the power of 6. So now replacing the value of x, we get 9c6, 2 to the power of 3 into 3 by 2 to the power of 6. Now simplifying this, we get this value to be equal to 21 by 2 into 3 to the power of 12. So what do we have to remember in this particular lesson? We just have to remember that if we are required to find out the numerically greatest term, this is not the numerically greatest coefficient. Remember it, this is the numerically greatest term. So we need to find out the value of this small m. You have to remember this particular expression. Put in the values of n, a and b from the given binomial data that will be given in the question, and check whether this value of m is coming out to be equal to an integer or not. If it is coming out to be an integer, then there will be two numerically greatest terms, and if it is not coming out to be an integer, then there will be one numerically greatest term, and that will be equal to the greatest term involving the greatest integer function of m, that is t of greatest integer function m plus 1. So this is how we are going to find out the numerically greatest term. So in order to find out the numerically greatest coefficient, we just have to find out the middle terms. So the middle terms of a binomial expansion will give us the numerically greatest coefficient. So in case the power is even, then there will be only one numerically greatest coefficient, and that will be equal to. So if we have a binomial expansion x plus y by n and n is even, then the numerically greatest coefficient will be corresponding to the coefficient of t of n by 2 plus 1, which in this case will be n c n by 2. Whereas if n is odd, then the numerically greatest coefficients will correspond to the two middle terms, which will be t of n plus 1 by 2 and t of n plus 1 by 2 plus 1. Therefore, the numerically greatest coefficients will be equal to nc n minus 1 by 2 and nc n plus 1 by 2. The values of these two coefficients will be the same, and they will be together the numerically greatest coefficients. Thank you.